Okay, this video is for people that are gone on Monday, the 29th. These are the different things that we're doing in class. There is no homework, but you need to prepare for your quiz. So I normally don't do the warm-up problem, but I want to make sure that we get this so that we know the difference, because if you can review the warm-up problem and the stuff we do in class, we should be good to go. All right, so we have two different types of angles we need to know the difference between. The first one is a central angle, and this is a central angle with its vertex on the center. A central angle is formed by the plural of radius is radii, and its vertex is on the center. So this is a radius, this is a radius, here it is on the center. Okay, compare that to an inscribed angle. This is inscribed. It's formed by two chords, and its vertex is on the circle. Okay, so visually they look different, and here on a central angle, the angle, I don't know, it's not right now, equals the arc. And on this one, the angle equals 1/2 of the arc. All right. For your quiz, you also need to be able to fill in one of these charts. We have done a bunch of them. Okay, remember if the radius is 9, that means the diameter is 18. The circumference is 18 pi. And then to get the area, you square 9 and get 81 pi centimeters squared. Okay, I'll do the last one. The area is 196 pi. So to get the radius, you have to take the square root of 196. So this is 14 feet. That means the diameter is 28 feet, and this is going to be 28 pi feet. Okay, that's the first thing I want to show you. The second thing is when class, we're going to fill in a formula sheet, and you cannot use this on the quiz, but I want you to keep it all on one paper so you can see it. So if the vertex is on the center, then your picture is going to look like this. This is a central angle. Okay. And when that is the case, the angle is going to equal the arc. The next option we have is when it was on the circle. Okay. So we had a picture that looked like this. This one is inscribed. Okay. We also have pictures that may look like this, that's not two chords, but like a chord and a tangent, but still the vertex is right there on the circle. And when that is the case, the angle equals 1/2 of the arc. Okay, option 3, inside, okay, but not the center. So that's when you have two chords that are intersecting, and it will look like this. And when that's the case, when it's inside, the angle equals 1/2, the sum of the two arcs. And your last option is when the vertex is outside, so it could look like this, or sometimes it would look like this. But when that's the case, the angle equals 1/2 of the big arc minus the small arc. Okay, and those are the 4 formulas you're working with. So now that we've got the formulas reviewed, let's do some problems where it's all mixed up and see what we need to do. So let's look at number 1. So it tells you it's not the center, and we want to find AEB. Well, AEB is this one, so I'm going to put my X there. And this time the angle, the vertex is right here inside the circle. So when it's inside the circle, the angle, which is X, is 1/2. And when it's inside, it's the sum of the two angles. So sum of two arcs. So we have to add 107 and 81. And 107 plus 81 is 188. So it's half of 188, which is 94. Okay, number 2, they want to find the measure of arc AB. When it's 2 letters, it's the shortest distance between the 2 points. So they want to find this arc right here. Well, this is a central angle because it's formed by 2 radii. The vertex is on the center. So the angle equals the arc. So this is just 165. Okay, Number 3, A, B, C. So I'm going to put my X where they want to find. This time the vertex is on the circle. So when it's on the circle, the angle, which is X, is 1/2 of the arc, which is 80. So X is going to be 40. Okay, number 4. They want angle JKI. So that is this angle right here. Okay, so there's our X, and our vertex is outside of the circle. So when it's outside of the circle, our angle, which is X, is 1/2 the big arc minus the small arc. So it's going to be 120 minus 50. So it's half of 70, which would be 35. Okay, number 5, they want DEG, DEG. So this angle right here, well, the vertex is on the circle, so this angle is going to be 1/2 of the intercepted arc. And this whole thing is the intercepted arc. And the intercepted arc is a semicircle, so it's got to be half of 180, which is 90. Okay, tells us that this is the center. And we want to find arc AB, shortest distance between the 2 points. Well, if this is on the center, then this angle over here that's marked 130 is a central angle because it's formed by 2 chords with the vertex on the center. So if that's 130, this is 130. And then we know that this is a semicircle, so they have to add to 180. So 180 minus 130 is 50. So this arc has to be 50. Okay, number 7, they want to find arc PQ. So 2 letters, shortest distance. This vertex is inside the circle. So it's inside the circle. The angle, which is 50, equals 1/2 the sum of the 2 arcs, which would be X plus 75. Now we can't add X and 75, so this is when we're going to clear the fractions. So this gives me 100 equals X plus 75. Subtract 75 from both sides, and we get 25 equals X. Okay, number 8, we want angle MNO, which is this one right here. Okay, so that angle is going to be half of its intercepted arc, and its intercepted arc is this one. We weren't given the intercepted arc, but we know this portion right here, and they have to form a circle. So if I do 360 minus 150, I'm going to get 210. So I know the blue part is 210. So now I know that X has to be half of 210 because its vertex was on the circle. It had to be half of the intercepted arc, which is going to be 105. Okay. Number 9, they want this arc right here. So 60 is the angle, and they want the arc. So this angle, the vertex is outside of the circle. So when it's outside of the circle, the angle, which is 60, equals 1/2 the big arc minus the small arc. Well, these I can subtract. 20 minus 60 is 140. So it's going to be half of 140. So it's just going to equal 70. Okay, last 3. They want MNP, which is this one right here. Well, the vertex is on the circle, so it's going to be half of the intercepted arc. Whoops. And the intercepted arc is 110. This right here is the intercepted arc. And half of 110 is 55. So this is 55 as well. Now this time it didn't ask for it, but this angle right here is another inscribed angle. Its vertex is on the circle, so it's also going to be half of the intercepted arc. And so it's going to be 55 as well, because if 2 angles have the same intercepted arc, then they are going to be congruent. Okay, arc LMN. So this arc right here, because when it's 3 letters, we start at L, go through M, and end at N. So LMN. Well, if this angle here is a central angle, then it's 124. Then this has to be 124, which is the other portion of the circle. So to find what's remaining, I can do 360 minus 124. And 360 minus 124 gives me 236 for this portion over here. Okay, last one. This one, K is not the center. And we want to find JKL. So this angle right here, JKL. The vertex is inside, so when it's inside, the angle equals 1/2 the sum of the two arcs. So that's 85 plus 100. So it's 1/2 of 185, which is giving us 92.5. Remember, in all these problems, when you're setting up the equation, you always want to make sure that you write the angle equals and then write whatever else you're doing. Okay, study for your quiz. Your quiz is Tuesday for the even hours and Wednesday for the odd.